treasure.
This book is so tough, Bear. Sometimes I just can't figure it out. Hector is almost impossible to find.
Daddy, I think I found some treasure.
Ah!
Hey, Daddy, come check this out.
Okay, I'm on it. Whoa, what is this thing?
It's a treasure chest.
Holy cow. Let's open it and see what's inside. What do you say?
Yeah.
All right, let's go.
Yeah.
Go for it. Look and see what's inside.
Okay. It's here it is. Seashells.
Whoa, a lot of seashells.
Cool.
Where do you get seashells at?
Underwater.
By the where?
The beach.
That's right, on the beach.
Yeah.
That's really cool. We're going to take a look at seashells today and just see what they have to do in the world of chemistry, okay?
Yeah.
I know you're excited. Do you think they're excited?
I think so.
Well, let's get started. What do you say?
Yeah.
So the treasure that Daniel and I just stumbled upon is actually a really great starting point to talk about our lesson today, reactivity between acids and bases. Now what we found were this. These treasures are seashells. Now, yes, of course, you find them down by the seashore, but what's amazing about seashells is they're formed, as you know, by taking calcium out of the water and adding some carbonate to it. Now, that's a polyatomic ion. But the calcium, that hard stuff, you're familiar with because it's the stuff that's in your bones. And so they're very hard, but as you probably remembered from last year's earth science class, that calcium carbonate reacts really well with acids. Now, in particular, what's kind of neat is you can take a seashell like this, and once the inhabitant has gone away, over time, sediments begin to fill it. And this is essentially a hardened, solidified stone. It's petrified. It's a petrified seashell. And all this is pure calcium carbonate, otherwise known as limestone. And what we're going to do right now is a quick and simple demonstration of something you are familiar with for what happens if you put in acid to test whether or not this actually is limestone. It's one of the lessons Miss Fiddler gave you last year when you were testing different types of minerals and rocks for reactivity. And this is one of them. Let's take a closer look. So here we have the limestone, and we're applying hydrochloric acid. Now, as we apply the hydrochloric acid, we see that the limestone begins to effervesce, and that's because the hydrochloric acid is beginning to bond with the calcium carbonate and completely reversing this reaction, taking an acid plus a base and creating something new. Now that we've seen the chemical reaction, let's take a closer look at the chemistry behind it. First off, let's look at hydrochloric acid. We see that hydrochloric acid is an acid because of the hydrogen ion in there. Now, if we look to the other side, an acid mixed with a base, in this case calcium carbonate, is going to be a base. Now, if we look at the charges associated, I think it's going to make a lot of sense for what we saw happen. We know that hydrogen is a group 1, but it's an ion. It's lost its electron. It becomes positively charged. Now, group 7, chlorine, the halogens, they all gain an electron. They will become negatively charged. So you've got a positive and a negative. This hydrogen desperately wants to be donated. That's what makes this a proton donor. Over here, we've got calcium, which is group 2. That's the alkali earth metals. They become positive 2 charge. But over here, carbonate, if you look it up on your periodic table, you'll see that it is a negative ion and it receives negative 2 charge. So what we're basically watching what happens is when this chlorine and this calcium get bumped from each other, they will form calcium, and because it's positive 2, we need 2 chlorine atoms. So they will form calcium chloride. So what we see here is the calcium bonds with the negative chlorine ion, and we need 2 atoms of it to balance out the +2 charge. Now that takes care of these 2 in the reaction. Obviously, some other things had to occur. Think about what you saw. You saw bubbles, and you saw bubbles effervescing out from this new chemical, this reaction that was occurring. Now and then there was runoff. There was a liquid running off of the reaction. Now what happens here is our hydrogen has to be donated to our oxygen. And what we end up making is H2O. Now, there's one more thing that's going to be created in this reaction. We've got some carbon that will still stick with our oxygen, and what we've created are those bubbles. That's the CO2 that we saw effervescing from the reaction. So we've taken hydrochloric acid and broken down the calcium from it. After the hydrogen ion is released, it goes into making water. And what we're left with is calcium chloride, water, and then of course the gas that was released in the reaction, the CO2. Now to balance everything out, on this side of the reaction, I have 2 chlorines and I have 2 hydrogens. To balance those out, I would need a 2 here for my coefficient to give me 2 hydrogens and 2 chlorines. But if we look, there's only 1 calcium here and 1 calcium here. There's 1 carbon to match with 1 carbon. There are 3 oxygens matching with 1 plus 2 other oxygens, 3 oxygens on this side. So this is now a balanced chemical equation, but it is an acid and a base reaction. What they have made is water and a salt. You're going to note that any time something bonds with the halogens, whether it be any metal, metals from group 1 or group 2, we actually call the halogens, that's chlorine's group, salt formers. And as you remember, group 1 has sodium in it, and chlorine will bond with that nicely, and what we call that is a salt. That's the most common you're familiar with, but there's lots of different salts. This happens to be a salt as well. Now, of course, we've got a gas expelling here, but all of this combined gives us a basis for understanding an acid-base reaction. Anytime you have an acid and you add a base, it will always yield a salt plus water. Now, of course, that doesn't necessarily mean that's all it produces. Sometimes there are gases formed, sometimes not. But an acid plus a base will typically yield a salt and a water because they neutralize one another. An acid can neutralize a base can neutralize an acid. And this is the foundation for the exact experiment you just saw. Now let's step back and try another one. Let's talk about a reaction that most of us, unfortunately, might be very familiar with. Let's say you're at dinner one night and you just so happen to eat something really spicy. Or, like in my case, always into add something that you like, which is spice, but maybe a little too much of it. So in that case, what you're actually adding to your already natural system is more of an acid to what your body already produces, as in stomach acid. That stomach acid is naturally produced to digest and break down all the food that you consume. But when you add an acid to another acid, you guessed it, you're making it stronger. And sometimes we get what's called acid reflux, or basically heartburn. That terrible, oh, it's awful. I know if you've had it, you understand. But there are remedies over the counter that people can buy. Now, some of them look like this, some of them look like this. Whichever you choose, it's something to settle your stomach. And the reason people take them is because they have something very important in them. They have a base, or something that's going to bind itself and accept some of those protons, the hydrogen ions that are running rampant all throughout your stomach. And so what we're going to do is take a step back and look at that as an experiment just to see the reaction, and then we'll break it down. Now, we could use either of these. This one is going to have the active ingredient, which is sodium bicarbonate. Now, that's a great one to use, but it also comes with lots of other additives inside of here, things that can help with indigestion, things that can also help with headaches. So we're not going to focus on this one per se. This one, however, has a very unique purpose, and all it's designed to do is to settle your tummy when it's upset. And what it uses is calcium carbonate. I think we've seen that before. So let's take a look at what it does when introduced to an acid. So we've got a basic experiment set up here to demonstrate what would happen inside your stomach. Now we're going to assume that each of these are going to be starting off completely neutral. To do that, I've got distilled water. Distilled water has taken all the impurities out, so all we're left with is pure dihydrogen monoxide. So we're going to add that to be a foundation for our experiment. So everything is running equal at this point. Now, since both of these are going to be representing what would be our stomachs, we're going to need to add something acidic to that distilled water. Now, I have some hydrochloric acid. Now, this hydrochloric acid is dilute to a 0.1 molar concentration, which is fairly good, but it's about 10% hydrochloric acid to water. We're going to take a small pipette, and I'm going to add about 5 drops to each of our quote-unquote stomachs. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, essentially, what we've got here is distilled water with hydrochloric acid in a small dose concentration, which would represent your stomach acid at this point. Now, what we're going to do is to introduce each of these so that we can see the same reaction. Now, you have to remember, these are chewables, and they're designed to be crunched up inside of your mouth before you ingest them into your stomach. So what I've gone ahead and done is to crush this into a powder. And on this side, it's meant to be dissolved in water and drank that way so that it's completely brought in. We're doing the same exact thing on this side, just crushed into a powder. We're going to start with this side so that we can see the reaction in our acid. So here we go. Now, one of the things we're going to note here, and if you can almost hear it, there's a little bit of bubbling going on there. It's starting to rise to the surface, but it's a slow reaction. And this is going to be something that would allow for your stomach to calm down over a longer period of time. Maybe it was a slight indigestion. Over here in this case, we might have some of that acid reflux where you might need to produce a lot of gas involved. And I think you're going to see that this one has a much more vigorous reaction when introduced to our acid. So here we go. And again, we see our carbon dioxide being released inside of here. as bubbles, and we've got a neutralization reaction, essentially trying to turn all of that acid, same as over here, trying to turn all the acid into what would be lower hydrogen ions. And in that case, taking the edge off of anything you might have introduced to increase the acidity of your stomach. Now, I think at this point you're starting to understand and get the gist of how acid-base reactions work. But I think we have time for one more quick experiment, and it's a fun one, and you could even try to modify it at home if you'd like. But please be careful. I am going to need an assistant for this one. Let's go get Daniel. So, what we're going to do today, we're going to launch this rocket. You know what we're going to use? We're going to use a little bit of science.
Maybe some goggles too.
Start off with safety. I like your attitude. Put those goggles on, buddy. Now you hold the rocket. Here's where our fuel comes from. What we've got here is vinegar. You know what vinegar is?
What?
It's an acid. And guess what? In this tube that we're going to sit our rocket down on to get it to launch, I've got baking soda. Guess what that is?
What?
A base. And guess what happens when you mix an acid and a base?
What?
You make a salt and a water. But guess what? In this case, we're going to make a lot of gas. And hopefully, that's going to launch our rocket straight up. Okay?
Okay.
So, hold the rocket like this. I'm going to pour in our fuel. Okay? So, here we go. Now, it does give us guidelines over here. There's a minimum we should pour in and a maximum we should pour in. I think we're gonna go for max.
Yeah.
All right. What does that smell over there? Does that smell good?
It smells like yucky cheese.
Yucky cheese is right. Okay, we're at the minimum. Hold it steady for me. We're at the middle. Hold it steady. Now we're at the max. All right, you hold the rocket. Let me put the cap back on our fuel, okay?
Is there no cap on this?
On that one, no, but on this one there is. So we put it there for safety. Now, are you ready? So, I'm gonna hold the rocket. Let's make sure everything is on there snug. Give it a place to fly, right?
No.
So here's what I want you to do. Come stand over here.
Is there a tissue?
There is a tissue. It's for safety reasons. I want you to come stand back over there. Okay? Now, the point is that the acid will mix with the base and it's going to produce salt and water, but it's going to produce a bunch of gas. All right? So this is going to go really quickly. Oh, we got some wind. Just wait for a second, okay? So before we get done, we're going to make sure we have our goggles on. Are you ready? All right. Here we go.
I'm looking in the sky. See how high it goes.
All right. You're on the rocket. Are you ready?
Yeah.
Here we go. In 3, 2, 1. Whoa! What'd you think?
Cool.
Awesome.
I thought I was gonna go higher.
Well, high five, dude. Hey, Daniel, did you have fun today?
Yeah.
I sure did. Thanks for helping me out with some of my experiments.
You're welcome.
Did you enjoy the rocket?
Yeah, it was awesome.
Did you enjoy it going up?
Yeah.
Do you know what made it come down?
It was like a space shuttle
Uh-huh.
floating up and then it came back down from the air.
What pulled it down?
Gravity?
Very good. Wow. Well, you know what we're going to do?
What?
I think we're going to close up shop here for this evening, and we've wrapped up another great lesson for the kids.
Yay!
Do you think they've learned a lot today?
Oh, yeah.
Do you think you learned a lot today?
Oh, yeah, I do.
What do you think you usually say at the end of every video?
I hope you love this video. Captain America!
And we're out. Okay, before we cut away too soon, I want to make sure that you have everything you need to know for the next 2 lessons because they're important. Today, we are wrapping up everything that we've been covering remotely so far. So, everything from reaction types, identifying reaction types, molarity, all the way through acids and bases, and everything in between, we are going to be having a review on with your homework tonight. So, everything that you're going to be working on that's going to be due Thursday at 10:30 before our class starts is going to be a review to help you go over all of that information at once. Thursday's class is going to just be me reviewing with you the homework problems and a few extras to make sure you absolutely understand it. Because a week from today, Tuesday, you are going to be having a assessment on everything that we've been covering. I'm going to be giving you practice assessments. I'm going to be giving you plenty of information to help guide you along the way, especially leading out into Tuesday. I'll be having open live conferences. Out into Thursday, I'll be having open live conferences so that you can ask me personally any questions that you have. And as always, I'll be recording those live sessions so that in case you can't make it to one, you can go back and review it before the assessment a week from today, Tuesday. So be on the lookout for that. Go over your homework that I'm giving you now and make sure that you thoroughly understand it. Because at the end of the day, as far away as we are right now from each other, we're still just sitting right here. And this stuff is not that complicated once you put all the pieces into place. So I want you to build on that with the homework tonight. Make sure that it makes sense. Raise any questions that you have during the review, and we'll go over it then. Until then, you reach out to me on Schoology. Make sure that I know if you're having any questions or issues that you've touched base with me, and just make sure that you're staying safe. And remember that you need to love the people around you because you are always loved. Bear, I cannot find Hector anywhere. This stuff is so hard. Thanks, buddy.